All right, hey scholars, we're going to talk about geometric probability. Now, the whole purpose of this is to figure out probability. We use it to actually do real world situations. I'm not going to give you a lot of examples of those, but a lot of times we can draw something geometrically, like to represent time or percentage of sales and what's the chance something would fall into a certain category in a business. We can use it by using geometric probability. Well, in order to do geometric probability, you have to know all your area formulas and your special right triangles. But I want to remind you what's probability, first of all, okay? Remember, in probability, we have what's called an event and we have a sample space. So here's the sample space. The sample space, we're going to roll die, okay? Now, on a good, normal, fair die, okay, there's 6 sides, correct? Now, what's the probability that when I roll the die, I'm going to get a 2? You guys remember doing this before? Well, we have what's called the sample space. The sample space is all the possible outcomes. Well, on a 6-sided die, the sample space is going to be what? 6 different numbers. So 6 different choices. But what's the possibility of me rolling a 2? Well, that's one choice. So that's 1, 6. So that's the probability, and I'm just going to put here, of rolling a 2. Okay, with the dice. That's what we're going to do. This is called an event. This is called the sample space. So when we do probability, how do we figure it out? It's the number of outcomes in the event. So there might be more than like one number, event, over the number of outcomes of the sample space. So that is probability. Well, what's geometric probability? What do we do with that? Well, in geometric probability, it is the probability of an event, okay, is based, that's an S there, sorry, on a ratio of geometric measures such, it's not right there, such as length and area, or we'll also find out degrees, like around a circle. So we could be able to do those. So here's an example of how an example of this would be. Now these are very simple geometric ones, but really all of them are going to be based off this. So we're going to have 3 different ways of calculating geometric probability. First one is using length. So we're going to use a line segment. And line segments can represent number lines, so that's really easy for us to figure out like time frames or when something could possibly have happened. But here, takes us like our first week back. You know, sum of the parts equal the whole. With the sum of the parts equal the whole type of scenario, I can figure out what's the chance if I was to run my pen back and forth and close my eyes and stop, what's the chance I would land on segment BC? We can figure that out using length. So here's our sample space. It's all the points on my line segment. So I'm going to use the length of my line segment to be my sample space. I want to know what's the probability, and the way I'd write that would be segment BC, of landing on segment BC. Well, that's the length of BC over the length of segment AD. That's one way of doing it. Another way is using angle measure or arc measure, all right? Because angles and arcs, they go all the way around, and it's how many degrees? 360. So what I want to know, what's the chance I would land on this sector, okay, or that angle of the circle? Well, I just need to figure out what fraction of the circle it's taking up. Well, that's when I use the degree measure, all right? Because all the way around, I know it's 360, but if I told you that angle was 60 degrees, you'd go, oh, 60 out of 360, that's 1/6. Well, that's exactly how you figure out the probability. So when I do that, that's the measure of the angle over 360, or the length of, or the degree measure of the arc over 360. Now the other one's kind of like darts, and I want you to think dart-wise. Like all of a sudden we have unique shaped dartboards, but there's a probability of, let's just say, landing on a certain field, like if you're sky jumping, or what is the chance that we would find a missing person in this kind of diagram? Now, understand this is a unique diagram. But when we do it, I think of area problems like you're hitting a dartboard. You have a new shape to your dartboard. Instead of a circle, we're going to have a rectangle. And it's everything inside that rectangle. On the edge of that rectangle is going to be our sample space. So that's going to be the bottom. So the bottom, you notice, is the area of the rectangle. But I want the probability of landing on that triangle. Well, how do I find that probability? Well, if I find the area of that triangle, I can figure out how much of that over the rectangle. So the area of the triangle over the area of the rectangle gives me the probability that if I was to throw a dart and hit that smack down there, what's the probability that we have? All right, so now what we're going to do is we're actually going to practice finding probability with geometric possibilities, and then very short lessons. So let's go to the next page.